Today we're going to learn lesson 10 of Unit 2, solving real-world problems involving trigonometric functions. So today's learning goals: after this lesson, you will be able to model real-world processes involving transformations of the basic sinusoidal functions, and then solve real-world problems involving trigonometric functions. Okay, first let's have a look at an example. So today we're not talking about too much theory. We'll use some examples to illustrate how we can model the real-world problem using trigonometric functions and then solve the real-world problems, okay? So first example is the range of arrow shot from a particular bow can be modeled by the equation r equals 100 times sine 2 theta, where r is a range in meters and theta is angle in radians. Above the horizontal that the arrow is released, a target is placed 80 meters away. A. What are the restrictions on the angle theta? B. Determine the exact value of the angle or angles that the archer should use to hit the target. Okay, so first of all, I'll give you 10 minutes to think about this example by yourself. And after that, we'll have a look at the solutions together, okay? Okay, have you finished? All right, so let's have a look at the solutions together. All right, so we have an archer that releases a arrow, right? So let's draw a sketch of this problem. Probably the arrow will travel in this trajectory, right? So the angle above the horizontal is here, denoted by theta, right? Suppose this is a target. Okay, so the function of the trajectory is given by r is 100 times sine 2 theta, and r is a range. So the distance is r here. And question A is asking what are the restrictions on the angle theta. So apparently the maximum value of theta can be is half pi, right? And the minimum value can be 0. So the restrictions on angle theta is from 0 to half pi, right? If theta is half pi, the arrow just travels straight up, right? Okay, so the restrictions on angle theta is from 0 to half pi inclusive. Next, determine the exact values of the angle that the archer should use to hit the target. Okay, so this time we know that r is 80 meters away, right? So when r is 80 meters, we put the 80 meters to the equation, and then we can solve for theta, right? Okay, so this is equivalent to sine 2 theta equals 4/5. And remember that theta is within this interval. If we draw a 2D Cartesian plane here, theta ranges from 0 to half pi like this, right? Okay, so in this interval, 2 theta can be arc sine 4/5, or sorry, I forgot to put if we want to solve 2 theta, first of all we need to determine which interval 2 theta belongs, right? If theta is within 0 to half pi, 2 theta must within 0 and pi, right? So this is the interval that 2 theta belongs. So in this interval, there are two angles whose sine value is 4/5, right? So first value is arc sine 4/5. The other value is pi minus arc sine 4/5, right? Okay, therefore, theta is 1/2 of arc sine 4/5, or theta can also be half pi minus 1/2 of arc sine 4/5, right? So this is the solutions of question B. All right, so you can also check the solutions on this lecture size after the class if you like, okay? All right, so let's have a look at another problem. The height h in meters above the ground of a rider on a Ferris wheel can be modeled by the equation here. H equals 10 times sine pi over 15 times the difference between t and 7.5, then plus a 12, where t is a time in seconds. At t is 0 seconds, the rider is at the lowest point. Determine the first two times that the rider is 20 meters above the ground to the nearest hundredths of a second. Okay, again, I'll give you 10 minutes to think about this question by yourself first. Then after that, we'll look at the solutions together, okay? You can start now. Okay, did you finish? All right, let's have a look at the solutions. Okay, I'll write it here. So basically we have a function. When h is 20 meters, this function becomes 20 equals 10 times sine pi over 15 times t minus 7.5 plus 12, right? And then we solve for x. So this function is equivalent to 5 equals 10 times sine pi over 15 times t minus 7.5. And this is equivalent to sine pi over 15 times t minus 7.5 equals 1/2, right? All right, so this is equivalent to, first of all, we find specific solutions in the interval 1 of the cycles, right? So we know that pi over 15 times t minus 7.5 can be 1/6 of pi plus 2k pi, right? One of the angles is here. And also there's another angle here, right? Which is 5 pi over 6 plus 2k pi. So we can also have this angle here equals 5 pi over 6 plus 2k pi, where k belongs to an integer set, right? Okay, therefore, we can solve, first of all, t minus 7.5 equals 15 over 6 plus 2k pi. All right, made a mistake here, not 2k pi. T minus 7.5 should be 15 over 6 plus 30k, right? Or from the second branch, we have t minus 7.5 equals 75 over 6 plus 30k, right? Where k belongs to an integer set. And therefore, t is either 7.5 plus 2.5 plus 30k, or t can also be 7.5 plus 12.5 plus 30k, okay? Where k belongs to an integer set. Now let's consider what values k can be, right? Because we want to find the first two times. So apparently that k is non-negative, right? That means t is equal to or greater than 0. So k cannot be any negative number, right? Because, for example, if k is -1, -2, etc., t would be negative, right? So the lowest value of k is 0. That means when k is 0, the first two times are t is 10 seconds or t is 20 seconds, right? So these are the final solutions we are looking for. Okay. Also, you can check the solution here. This is more complete and clear. Okay. You can check the solutions here if you like after the class. All right, so next, let's consider another example here. So this time we have a diagram showing the cross-section of a water channel. The equation that represents its boundary is given in this equation here, where x and y are both measured in centimeters. The top of the channel is level with the ground and has a width of 24 meters, as shown in this graph. Okay, the maximum depth of the channel is 16 centimeters. Okay, the question is to find the width of the water surface in the channel when the water depth is 16 times square root of 2 minus 1 centimeters. Okay, we want to find the water depth here. Okay, again, I'll give you 10 minutes to think about this question. Okay, did you finish? Okay, let's have a look at the solutions. Okay, so basically, we want to find length of the length between these 2 points, right? So first of all, let's mark this point as P1, this point is P2, and this point is P, right? So basically, we want to find, if we can find the y coordinate of P, we can use 16, which is the length here. Length here is 16, right? We can use 16 minus the absolute value of the y coordinate of P. Then we can get the water depth, right? Okay, so basically we want to find the coordinates of P, or P1 or P2. Okay, so apparently, so let's denote P1 as x1, y1, P2 as x2, y2. So basically we know the equation of this curve, right? And we also know that the x coordinate of P1 is sorry, let me restate this question. Just made a mistake there. Actually, we know the water depth, right? And we want to find the width of the water surface, right? So that means we want to find the x coordinate of P1 and the x coordinate of P2. And then we know the distance between P1 and P2, right? And we also know that the y coordinate of P1 and the y coordinate of P2. Okay, so basically the question is converted to, we know that the function is minus 16 minus 16 times square root of 2 minus 1. And find x. Okay, so basically the y coordinate of P and P1 and P2 is this value here, right? So let's put this value in this function given here. And this equals 16 seconds pi x over 36 minus 32, right? Then we have an equation here, and then we need to find the value of x's, right? Okay, so this equation is equivalent to square root of 2 equals secant pi x over 36, which is equivalent to secant something is a reciprocal of cosecant, right? So cosecant pi x over 36 is square root of 2 over 2. Therefore, pi x over 36 is, so first of all, we can find an angle in one of the cycles, right? So this angle could be a quarter pi, but in order to find all the values, we need to plus 2k pi, right? Or pi x over 36 can also be minus a quarter pi plus 2k pi, right? Where k belongs to an integer set. Okay, therefore x is 9 plus 72k, or x can also be minus 9 plus 72k, right? Where k is an integer. Okay, now let's consider the constraints for x. Because x is within minus 12 and positive 12, right? Because the minimum value is minus 12 as shown here, and the maximum is 12, right? Therefore, so let's check the value of k. Let's check if k can be any negative value. If k is minus 1, apparently the first value is not within this interval. Second is not in this interval either, right? So k cannot be negative 1, negative 2, negative 3, etc. So the minimum value of k is 0, right? So when k is 0, x is 9, or x is minus 9, right? And can k be any value that is greater than 0? So let's check. If k is 1, apparently 72 plus 9 is 81. 81 is not within this interval, right? So same thing will happen for the second solution. When k is 1, x is 63. 63 is also out of this interval, right? So k cannot be any value that is greater than 0. So the only value that k can be is 0. All right, so that means we find the corresponding x coordinates. That means x1 here is minus 9, and x2 here is 9, right? So the width of the water surface is 9 minus 9, which is 18 centimeters, right? Okay, so now let's make the conclusion. The width of the water surface is 18 centimeters, okay? Because the width is just 9 minus 9, which is 18 centimeters. Okay. All right, you can also check the complete solution in this lecture slides if you like after the class, okay? All right, let's have a look at another example. Seasonal variation in temperature. The variations in maximum daily temperatures for Moose Factory, Ontario on the first month from January to December are shown. Write a sign function to model the data. Okay, again, I'll give you 10 minutes to think about this question, and after that, we'll have a look at the solution together, okay? Okay, have you finished? All right, let's have a look at the solution together. So basically, we want to model this data using a sine function, right? So the sine function can have the form t equals a times sine k times m minus d, right? M stands for months, and T stands for temperature. And then plus C, right? And then we need to determine the 4 parameters according to the given data. So according to the given data, the minimum value is minus 14, right? So this is the minimum value. Maximum value happens here. Maximum value is 22.4, right? So that means the amplitude A, actually the absolute value of A, right, is 1/2 of maximum minus minimum, which is 18.2, right? So we can just let A be 18.2. So we have solved the first parameter. Next, we consider the value of K. So the period, usually if you model a data like this, we consider 1 year is a cycle, right? So the period is 12 months, which is 2 pi over the absolute value of K. So that gives us the absolute value of K equals pi over 6, right? So we can just let K be positive 1/6 of pi in order to achieve simplification, right? All right, so the other reason, okay, so next one is to determine the value of D, right? So apparently D is a phase shift. So if there is no phase shift, you know that the first maximum value would occur at a quarter of t, right? Quarter of the period, which is 3, right? But now we know that the first max occurs at m equals 7, right? That means there is a phase shift to the right by 4 units, right? And therefore the phase shift is 4 units to the right. And therefore we know that D is actually 4, right? Because we have 4 units to the right. And last, we need to determine the value of C, right? C is just the 1/2 of the minimum value plus the maximum value, which is a vertical translation, right? So this is 1/2 of minus 14 plus 22.4, which is 4.2, right? Okay, so this function is, okay, all right, here. So this function is determined. T is just 18.2 times sine K is pi over 6, and then m minus plus C. C is 4.2. Okay, so basically we can use a function like this to model the given data. Okay, also you can check the complete solution in this lecture slides after the class. Okay. All right, so let's have a look at another example. So this time we have a depth d meters of water in a harbor, varies with the tides during each day. The first high maximum tide after midnight occurs at 5 a.m. with depth of 5.8 meters. The first low minimum tide occurs at 10:30 a.m. with a depth of 2.6 meters. So there are two questions. First, find a trigonometric function that models the depth d of water t hours after the midnight. B, find the depth of the water at 12 noon. Okay, again, I'll give you 10 minutes to think about this question first. And after that, I'll look at the solutions together, okay? All right, let's have a look at the solutions. Okay, so this function is basically have a pattern like this, right? The depth of the water varies during the day. So the x coordinate is time, and y coordinate is d, right? And we have some maximum values and minimum values as the d varies with t, right? So the function will have a form like d equals a times sine k times t minus m plus c, right? We need to determine the value of a, k, m, and c, respectively. Okay, so first of all, we know that the maximum value of d is 5.8 and minimum value of d is 2.6, right? So the amplitude of the amplitude, which is the absolute value of a, is maximum minus minimum over 2, which is 1.6, right? So we can just let a be 1.6. And then we know that the first high occurs at 5 a.m. and the first low occurs at 10 p.m. at 10:30 a.m. So first max to first mean, that's 1/2 of the period, right? So 1/2 of the period is 5.5 hours, right? And this gives us the period is actually 11, right? And period is given by 2 pi over the absolute value of k. So that means the value of the absolute value of k is actually 2 pi over 11, right? So we can just let k be 2 pi over 11. So that means we have the value of k now. Next, let's consider the phase shift. So first of all, if there is no phase shift, we know that the first max would occur at t equals 1/2 of the period, right? Which is 1.75. But now the first max occurs at 5, right? 5 a.m. Because we start marking the time at midnight. So the original point is midnight, which is 0, right? So that means the first max occurs at 5 p.m. That means the phase shift is 5 minus 2.75, which is 2.25 to the right, right? Because if there is no phase shift, the first maximum happens here, and now we find it here. That means the phase shift is 2.25 to the right. Okay. Okay, that means the value of m is 2.25, right? Okay, now we determine the value of m. Last, let's consider the value of c. Okay, the value of c is simply 1/2 of the mean plus the max, right? So this is 1/2 of 5.8 plus 2.3, which is 1/2 of 8.4, which is 4.2, right? Okay, so we have all the parameters here. So the final solution of the function is d equals 1.6 sine 2 pi over 11 times t minus 2.25, then plus a 4.2, right? Okay, so this is the first question. Next, question B wants us to find the depth of the water at 12 noon. So at 12 noon, that means when t is 12, right? When t is 12, d is just, let's put t equals 12 in that function. 1.6 sine 2 pi over 11 times 12 minus 2.25 plus 4.2, right? This is 1.6 sine 19.5 pi over 11 plus 4.2. In order to calculate this, you will need a calculator or spreadsheet on a computer, right? So the final solution is approximately 3.152 meters. Okay. All right, you can also check a clearer, more complete solution in this lecture slides, if you like. Okay, I'll give you some 1 minute to have a look at the solution here. All right, so let's make a summary of today's lesson. So now you should be able to model real-world processes involving transformations of the basic sinusoidal functions and solve real-world problems involving trigonometric functions. Okay, so before the end of the class, I need to remind you that in our next lesson, which is U2L10, we will have a axis test, okay? We'll take the test 2. So please get yourself prepared for test 2, okay? The scope of test 2 is U2L1 to U2L10. And you can use homework and lecture slides as review materials, okay? Also, please do not forget to complete and submit today's homework before the deadline, okay? All right, so you can use the rest of the time to do today's homework now.